Hello, everyone, and welcome to today's class on regression and building predictive models in supply chain management. I hope all of you are doing well. So today's class, we're going to be discussing regression, as I just mentioned, and this is something that has been being used for a number of years now. Well before artificial intelligence came into being, regression was being used to make predictions um, in various fields. So if we really just take a look at what regression is a statistical method. So it involves looking at a lot of numbers and analyzing those numbers using statistical methods. And regression has been being used in finance, investing, and a number of other disciplines. And the whole idea of regression is that regression helps identify a relationship between one dependent variable and one independent variable. So, usually the dependent variable is known to as y, the y variable, and the independent variable is known as the x variable. And there may be more than one independent variable. So you may have a rather long regression equation with, x1, x2, x3, x4, various variables, but there's always going to be one y variable. And I'm going to explain this using a couple of examples. So let's try and get our a greater understanding about the relationship between x and y. Just imagine you are in the market to buy a house. Now, if you have, you're going to go to a real estate agent and you're going to ask him to give you certain pricing. And the prices will vary, right? There's going to be some houses that are going to be very, very expensive. Some are going to be medium, and some are going to be, really cheap. And so if we kind of want to understand what variables are going to be determining the property price, there may be a number of different variables. There may be a variable of how big the house is, the area of the house. So obviously, if it's a really huge mansion, it's going to be a lot more expensive than if it's a tiny apartment. The location also matters. So if it's in a very popular location, the price of the house may be more versus if it's really in the outskirts of the city. The number of bathrooms, the number of amenities, perhaps availability of water and light, excuse me, light, and all of these various factors determine the property value. So in this example that I just gave, the price of the property would be the y variable. It is dependent on a number of other x variables. And those x variables, as I mentioned, include the area, the location, the number of bathrooms, availability of light, availability of water, so on and so forth. And so here you can see that, there's always, in this example that I just gave, there's one y variable, one outcome, the property price, but it's dependent on a number of different x variables. I'll give you another example as well, just to clarify the x and y variables in regression. Let's think about a company and the amount of sales that it made in the last month. So, sorry, in the current month, the amount of sales that it made. So if you want to look at the amount of sales that are being made in this month, you may have to, that will really depend on a number of things going on, right? It may depend on how much advertising was done, what the price of the good is, the seasonality, there's certain, during festivals like Eid, there's usually higher sales versus, during normal days. Also have is has the amount of competition. Perhaps a new competitor has come in and is offering a better product at a lower price. So there's so many factors that could affect the sales that a company is being able to generate in the current month. So if we look at this example that I just mentioned, the sales that are being generated in the current month is the Y variable, and it is dependent on a series of different X variables, which include, things such as the advertising, the price, seasonality, last month's sales, and there could be many more. So hopefully by understanding these examples, you have a better grasp now of what independent and dependent variables are. Again, before I leave, just please remember that the dependent variable is the Y variable. So again, in the property value price, for example, the price of the property is the Y variable, and the factors that impact the property price are the independent variables, or the X variables. And there can be more than one X variable, but there can only be one Y variable. Okay, so now, moving on, I just wanted to talk to you a little bit about what regression is. And really what regression is it's sort of like, just to give you an example, let's say that this is, I'm going to just show you a relationship between two variables, okay? The cost per load and the amount of miles that is traveled. So let's say this is a truck. The cost per load is obviously going to increase if it's going further distances. So for example, if a truck is traveling just 200 miles, then it will have a cost of, let's say, $1,300 per load. But if it's traveling, 1,600 miles, then the price would be a lot higher, maybe around $3,800 dollars per load. So here you can see, a trend, an increase. So as the distance increases, the cost per load increases. Now on this graph over here, what has happened is that a lot of real life examples of actual truckloads that have been moving have been plotted, right? So the blue diamonds really reflect actual incidences that have happened. And the regression line is a line that kind of is going through these, actual incidences, and it's making, it's almost as if it is determining a kind of an equation, a linear equation. And, it's determining, this line has a slope, right? So it has a slope, it has an intercept. So for example, if it's like a really, right at zero, what is it, what is the cost per load? So just, to move anything, you have to pay, the starting price of moving anything is 1,000. And so you have to pay 1,000, and then there's an incremental value that is established by a trend line multiplied by the actual amount that is traveled. So in this case, the cost per load is the Y variable, right? So cost per load is right here, the Y variable, and the intercept, or the price that you have to pay just to use the service, is 1,000 here. And then there's a factor of 1.75, which is the slope, multiplied by the actual distance that is traveled, right? So this is the formula, that the regression formula that is generated by, by applying the regression function in Excel. It doesn't really give it to you written like this. I will explain to you how, what regression, what shows up in Excel when you run the regression function, but you will be able to make a similar equation when you look at the results of the regression in Excel. So one thing you need to understand is that the way Excel or the way regression is calculated is that it minimizes the error or the difference, from this line to these actual dots. So the function tries to minimize the gaps between the line and what has actually happened. So the idea is to make this line as accurate or as close to the reality as possible, and also determine an actual equation. One thing you do, need to keep in mind is that even if the regression equation is very, very accurate based on actual data, there is still a little bit of difference between the line and actually what's happening. So that is known as the residual value. Okay, and the residual value or the error. And the whole idea is, again, as I mentioned, to reduce the error as much as possible. So E is what is used to kind of identify the error. Also, the word residuals is known to really measure the difference between the actual incidences and the linear equation. Okay. If you really want to learn a little bit more about how Excel is calculating the regression line right over here, how is this line being calculated? Well, and it is using a formula, which is the ordinary least square regression formula. And the whole idea is that it's using this formula helps reduce the errors, reduce the amount of errors. So make the line as close to the actual incidences as possible. Again, here, I just want to really kind of reiterate everything that I have just explained. The error term, E, is the unaccounted or unexplained portion. Eventually, when you make do a regression in Excel, you are really trying to establish a linear equation. And in a linear equation, as I showed in the previous slides, there is always an intercept. And so just to use any service or to use a product or to really get going, this is the intercept at 0. What is the value right over here? There's always going to be some sort of, in a linear equation, some sort of a slope. And then there's going to be the actual x value that you will be multiplying it by. And there is going to be an error inevitably. No matter how accurate a regression line is, there is an error. And the whole idea is, really good regressions have a lower amount of error as compared to a bad regression line, right? The idea is to minimize the error. So that is what this equation, the ordinary least square regression equation, does automatically. All right, for the purpose of this lecture, I will be using an example of Duffy Industries, and there is an Excel sheet that is embedded in the lecture slides. I will also be adding this to your LMS so that you can download it and really practice. And if we really kind of just take a snapshot of what's going on over here in the Duffy Industry example, there is a cost per load, okay, that is the Y variable, and it is dependent on a number of different variables. So the distance, the lead time, so trailer length, the weight, equipment, a lot of different variables. So as we kind of mentioned, we are going to try and build a relationship. So these all are going to be the independent variables, right? and then there's going to be one y variable, and we can sort of mix and match. So y is going to just be one, but we can sort of see, okay, if we take one x variable and try and find the relationship with y, such as, for example, we try and make a relationship or a regression between distance and the cost per load. That can be done. We can also take two variables and say, okay, well, we want to do a regression between the cost per load, which is the y independent variable, and we want two x variables, the distance and the weight. So you can really have more than one. You can have either one, or you can build other models where you can have more than one x variables, and sort of see what happens, what the results are like. And I will also talk to you very briefly about how to choose between which model is the right model to choose, because it's not always necessary that, the more X variables there are, the more accurate the model is. Sometimes that's definitely not the case. In fact, there could be just one X variable and one Y variable, and that could be a lot more accurate than having one y variable and several different x variables. It really depends on the results of the regression, and you have to look at the results of the regression to determine, the right equation, the right regression equation that really is going to give you the most accurate regression equation, which you can use to make predictions going forward. If you use the wrong equation, obviously your results will not be very accurate, and your predictions won't be accurate either. So again, please keep in mind that the whole objective of doing regression is making predictions. And I'm just going to go back here for 1 second over here, right? And so here, once you have a line, once you have an established regression line, you can make predictions for, if what happens if a truck goes for 1 million miles, what is the cost per load going to be? You can make a prediction for, just looking at this, what is it going to be if it's 3,000? What is it going to be if it's 0? So, this line, this regression line, the end objective of doing this is to build predictive models. And you need to, the whole idea is to also, and I will be showing you through Duffy Industries example, to really try and understand what the right formula is for the prediction line. So, and as I mentioned, how many X variables do you really want to have? So I'm going to be talking to you a little bit about all of this using actual models. So we are going to build 4 prediction models, and we are going to sort of analyze them and determine which one, which one we should go for. So again, if you open up the Excel sheet, which I will be doing in a little bit, you will see, something like this, where y is the cost per load, and these are a number of different X variables: the distance, the lead time, the trailer length, the weight, the equipment. What will happen once you, and I will show you this when I actually do the examples, but what will happen when you run the regression model is that you will end up with a report. Excel will give you a report, and that report will have a number of different statistical variables on it. It's going to show you the R-square, the adjusted R-squared, the root mean error, root mean squared error, the ANOVA, meaning sum of squares, degrees of freedom, and several other variables. The ones that I want you to focus on for this class is the p-value, okay, the p-value, and the adjusted R-squared. So these are the 2 variables that I really, really want you to focus on. And just 2 slides, a slide ahead, or basically 2 slides ahead, I will be talking to you a little bit more about the adjusted R-square and the p-value. Before I move on any further, for any of you using Excel to do regression, please follow the steps outlined in this particular slide to make sure that you add the regression functionality in Excel. So in many Excel packages, regression functionality doesn't show up automatically. You need to add it in. It's free to do that, but basically you have to go in Excel and click File and go under Options. And once the Options dialog box opens, click on Add-ins, okay, and make sure Excel Add-ins is selected. Go into the Manage box, click Go, and basically you have to choose, within the add-ins, you have to choose the Analysis Tool Pack. And then you click OK. And once you do that, you only have to do this once to install the Analysis Tool Pack. Once the Analysis Tool Pack is installed in your Excel, you will automatically easily be able to use regression going forward. All right, as I was just mentioning to you a little while ago, the two variables that I would like you to just really focus on for the case of establishing which model is better, comparing map models and establishing which model is better than the other, is the first one is, sorry about that. The first one is the p-value, and so again, as I was just mentioning, the p-value and the adjusted R-squared are the two basic metrics that we are going to be using when really analyzing models. So the lower the p-value, the greater the statistical significance. So the lower the p-value, the better the situation is, the better the model is. What is a p-value? A p-value is the measure of probability that an observed difference could have occurred just by a random chance. So you don't want things happening by random chance. You want things happening according to the model. And if there's a high p-value, that means there's a lot of random things happening and the model is not really working very well. So in that case, you don't want to really go ahead with using that model. The other metrics is the adjusted R-squared. And this is also known as the coefficient of determination. Now here, the higher the R-squared, the better the situation, right? And basically adjusted R-square indicates how well the term fits a curve or line, and it adjusts for a number of terms in the model. So again, the whole idea is it's talking about how well terms fit the curve or line. So how close is the actual things happening to the curve or the regression line? So the closer it is, the higher the adjusted value, the better the model. So these are two very important things to remember when you are going to be looking at various regression models and determining which one is better than the other or comparing them. Okay, next I'm going to be actually taking you through 4 different models and calculating the regression for each one of the models. And the data I am going to be using is Duffy Industries data. In the first model, I will be talking to you about a situation where the cost per load, the Y variable, is a function or is dependent on one X variable, which is the distance traveled. So now I'm going to take you through the actual example in Excel. Okay, so in this particular example, now I'm in Excel, and this is just the raw data. I'm actually going to be going on to model 1. And here I am going to be going into data first. So the regression functionality, in order to use it, you have to go into data. And once you have installed, regression, you can click data analysis like so. And you are going to basically find regression and press OK. And you are going to input the y variable, which is, it's always best to click labels, because then you can include the first variable. Also, it's much easier to read in the final report. And you're going to click, oops, sorry about that. You're going to go here. You're going to click the CPL, cost per load, which is the y variable. And I am going to sort of just include all of the 100 instances. Okay, so again, I have included CPL in the y range because this is the y variable. And next it's the regression function is asking me what is it dependent on, and I am saying it, please make it dependent on the distance. So I'm going to just go into X variable. I'm going to go into distance, and I'm going to just click and drag all the way to the end and press OK. And so this is my report. Okay, so this is my summary report. Okay, so model 1 regression report. And here I can see that, okay, let's look at the R squared. It is, okay, I'm going to actually make this to 2 decimal places because it seems a little bit lengthy otherwise. So our adjusted R squared is 0.82. Maybe I can make this to 3 decimal places. So let's say, okay, this is the main thing that I'm looking at. I'm also, because I want to be, build an equation, I want to look at the intercept value. So this is 1,282. And the distance slope, this is the slope value, 1.53 is the slope value. Okay, so basically what I can easily see is that the according to this model is equal to 1282. I'm rounding this value up, plus 1.53 into x. Okay, and the x value I can add. So this is how I have made a formula out of looking at this report. And also I'm going to be looking at the p-values. These look very, very low. That's a good idea. But I'm actually going to run a couple of other models as well before I determine what I really think of this particular model as compared to others. And in your actual slide deck, you can, oops, I'm on the wrong slide. You can also see the same results. Here again, everything is repeated. So the CPL is equal to 1,282 plus 1.532 multiplied by x, which is in this case distance, right? Remember the x variable that we are looking at is distance. So then we have this equation now. If whatever distance you can plug in over here, you will be able to predict the cost per load very easily. Again, we're looking at an 82%, adjusted R squared, and that's pretty good. We are also seeing that the p-values are very low. They are less than 0.0001. So that's very good. So these models do look good. But as I mentioned, we will be looking at 3 other models before we determine like which one we think is the best one. So the next model we are going to be looking at is a model where there are actually 2 x variables, distance and weight. Obviously, there's only one y variable, which is the cost per load. So the cost per load, we're going to see what, we're going to build an equation and check to see, what the results are if we make it a function of distance and weight. Okay, so now whenever you have a situation where there are 2 different x variables, before you run the regression functionality, it's important that the 2 x variables are next to each other. So in this case, I am just going to simply delete these 2 because we really don't need that. And I'm also going to just delete equipment. We just are saying that CPL is a function of distance and weight. So we want to run a regression on that. And again, I'm going to go into data analysis, regression, and I'm going to choose, I'll just choose the Y variable just to be on the safe side. Yeah, really quickly. And now the way I'm going to put in two X variables is I'm just going to highlight them both and click and drag all the way to the bottom. And then I'm going to say, just going to check everything, new workbook, that's fine. I want the labels, and this is my new report. So this is the model 2 regression report. And let's have a quick look. The adjusted R squared looks close to the previous model. So it's at it's at 0.81 now. So it's a little lower than 0.82 in the previous one. Let's look at a couple of other things. The p-value, oops, this p-value is pretty high as compared to the others. The other ones are below 0.0001, but this one is pretty high. So that's not a good situation. This is a little bit of a warning signal. Let's now also make the equation looking at this. So CPL is what, our dependent variable or our Y variable is. Our intercept is right over here. So it's 1,354 plus 1.54 into distance minus 0.003, and this I'll say is the into weight. So if we want to make a prediction, we can add the distance value, the weight value, and we will be able to calculate the cost per load just looking at this report. So again, your slide deck also sort of shows these results. And again, we saw that the adjusted R squared got slightly worse. So it was, 81% became 82. Sorry, it was 82% in model 1. It kind of went down to 81, around 81.5%. And we saw that the p-values for the intercept and the distance were still very low, but the p-value for weight was high, which is not a good situation. So this model is not necessarily better than the previous one. Comparing 1 and 2, 1 is definitely better. Okay, so now even though we had two variables, but two independent variables in this equation, but if you just look at the results, that indicates that model 1 is better. Okay, now let's move on to model 3. And here CPL is a function of distance and distance squared. So this is the new model that we now are going to be making. Okay, now when I look at this, I can see that their distance is given, but there's no distance squared. So that basically means we need to calculate distance squared. We do not need these other variables. So I'm just going to go ahead and delete that. And I'm going to say, distance squared. I'm going to add that over here. And I'm actually going to, I'm going to go ahead and calculate that. Okay, so this is the distance squared. Right, and now I'm going to run the actual regression. Okay. Right, so here is the Y variable. And I have my two X variables next to each other, so that's really good. I'm going to just highlight them together. And labels is clicked, that's good. I've clicked new workbook, excellent. So we're good to go. And this is my model 3 regression report. And let's look at what's happening here now. Okay, and let's try and compare it with our other models. And here, let's look at, first of all, let's look at the adjusted R squared. It's going down. It's lower than even the model 2 one, right? So here it was 0.814. Now it's gone down to 0.8139. Also, let's look at the p-values over here. This is really okay because this is low, right? But these two are high. They are, especially distance squared is very, very high. That's a warning signal. We definitely do not like model 3 very much. But regardless, I will make an equation out of this. And here I will have my intercept, and I'm going to round this up to 1,236. And the distance is, 1.62, and that's distance minus 3.945, and this is going to be distance squared. So if I put in these values, I will be able to predict the cost per load. But again, this compared to the other, models, this model does not look good. So far, the rank is, model 1 is the best one, then model 2, and then model 3. I actually made a slight error over here, which I do want to mention to you. This is something that one can get stuck in. If in Excel you see something like this, minus 3.945, and it says, at the end it says E minus 0.5, that basically means that you have to, this is basically, I'll show you what it is. It is minus 0.1234. This is what the equation, this is what this number is. Okay, so if you do not, you have to look at it a little carefully, right? So when it says E minus 0.5, this basically means take this back 5, it's 0.000. You have to sort of take a decimal places back, take it back 5 decimal places, and so that's what the final thing is. So here, this equation is actually going to be, okay, and again, if you really kind of just look at your deck, it shows you pretty much exactly the same thing, right? And again, over here, we notice that, look, these p-values are good, but this one is really, really high. So that's why it's not a good idea. This model has a couple of good things, but a couple of bad things. So again, we have rated model 1 as the best, model 2 is second best, and model 3 is the third best so far based on our analysis. Now next, in model 4, we have a little bit of a different situation. We're going to look at a model where the cost per load is dependent on distance and also ref flag. And ref flag is basically, in this particular situation, we are going to be adding a dummy variable. So let me just take you back a couple of slides right over here, just to explain to you what's happening. So they are basically in model 4, I'm going to show you, you see, we can't run a model with, if we put in we put in dry and ref in these kind of terms, these words in the Excel model, it will not work. It does not work. But what can happen is that we sort of make this a dummy variable. And by dummy variable, we basically mean you either make, since there are only 2 variables over here, one is dry and one is ref, you make one variable 0 and one variable, you know, 1. And for example, in model 4, we are going to make all the ref values 1 and all the dry variables 0. And that's how we are going to run the model. So now let me show you exactly how that is done in Excel. All right, so now I am back in Excel, and I, kind of know that there are two variables that we need to take into account in model 4. All right, so the first one is, let me just write out the equation because that always helps. So is equal to a function of distance and, ref flag. Okay. And this will always be mentioned to you if in the question, which of these dry or ref should be made 1 and which should be made 0. Okay, so in this particular case, we only need distance and we need this equipped variables. So I'm going to go ahead and delete the rest, and I'm going to make a situation where I'm just going to put 1 in front of all, and you can use an if functionality to do this, and that's usually a lot quicker, but I'm not going to introduce that to you now. I'm just going to do this really, really quick. Okay. Or maybe I should just put in the functionalities, it would be easier. So if, and we go here, is equal to dry, then put in 0, otherwise put in 1. Okay. So the correct formula for the if functionality is this one: if D2 is equal to, and make sure you put about 2 apostrophes over here, dry, then it's equal to 0, otherwise 1, and you close the brackets, and then you just click and drag, okay, all the way to the end, okay, and so this is what it comes down to. And now I'm just going to run a regression. So I'm going to go into data, right over here, regression, CPL is correct. We had that before. And in this situation, whoops, I need to actually, I'm just going to delete this now. We don't need this. Oh, goodness. So what I'll do is I will put this next to it this way. And then I will do the data analysis again. So I'll do regression. We've got that going correct. And I'm just going to do this. Okay. And then I'm going to check the labels are clicked. Okay, new workbook. And so this is model for regression report. And in this situation, let's have a quick look. Adjusted R squared. This is better. This is good. Now let's look at the p-values. Again, we see a e minus 22 at the end of the p-values. That means this is really a low 0.0000, really, really low value. That's very good. This is high. This is not good. This is very high. This one is also low because it has an e minus 38 at the end. So because of this p-value, this model doesn't look that great. So again, model 1 is the best one based on this analysis. Now I'm going to just make the actual equation looking at this. So it is 1,200, and I will round this up right over here, 1,236 plus 84.15 into equipped And remember, this value is either going to be a 0 or a 1 that you will multiply over here, okay, plus 1.53 into distance. So this is the final formula that we have. So your slide deck also shows pretty much the same, you know, with a little bit of a rounding difference, but the same equation, and again, pretty much the same kind of analysis that I just kind of mentioned, that this p-value is a little higher, that is a poor p-value. And so this does not necessarily look like the best equation. Now, with that being said, I hope you have gotten a good understanding now of how regression works, what the idea of regression is, why it is done, how it is done, and how you can compare various models of regression. I would highly recommend, I will be sharing the data. I would recommend that you do practice on your own. I will also be giving you some practice questions for regression. But I would suggest that you know, practice, and that's the best way to get really comfortable with regression. Finally, just want to share a couple of regression assumptions. So again, regression by far is not, you know, like, I mean, there are certain assumptions that are inbuilt into the model. The first one is that a population regression line joins the mean of the dependent variables. The mean of error is 0. The dependent variable is normally distributed, and error terms are probabilistically independent. So, you know, again, the whole, I don't want you to get into the nitty-gritties of it, but I just want you to remember that there are certain assumptions of this model. It's not like it is always, you know, perfect. There are certain assumptions, there are certain, and it's built on those assumptions, such as the mean of errors is 0. Now, you know, that may be true, maybe not true, but these are just certain assumptions that are taken into account. So with that, I'm coming to an end of this lecture. I hope you enjoyed it. I hope you got a good overview of how regression is used to build predictive models and supply chain management. I look forward to having an interesting discussion on this topic with you soon. Thank you very much.